So, whatever we discussed for the last almost 2 hours, I would like to brief it that in case of frictional perspective in mechanical system, it is definitely analogous or similar to electrical system resistance that offer due to flow of current. In case of electrical resistance is similar to mechanical system friction, and the core region of friction is mass, nothing about temperature or surface area or anything that can influence on the friction. The friction only absolutely depending on mass. So in electrical system, whenever it offer high resistance, definitely you need to apply more electric field or force to follow current or to allow current. Here also in case of frictional system, you need to apply additional force to make the system movement or in accelerating. So in that case, the action of force, if it is not, it is just counterbalance the friction, then the P and Fs should be equal. But if P itself has certain angle, then depending on the angle, the cosine function of P should be equivalent to Fs. And normal force and force due to gravity should be counterbalanced. But whenever there is a slope, then definitely the P force cosine function should be added with the normal force. Definitely the uh, friction should be higher. If it is downward, friction should be lower. And that is the baseline principle is the Newton classical mechanics, F equal to ma. Whenever the mass action should be higher, definitely force should be higher to make it some speed or acceleration. So in case of moment of inertia, the core thinking is that moment and moment of inertia, how they are related, how torque is involved with the moment of inertia, how angular acceleration and linear acceleration is related, how they are interrelated. You know that the moment of inertia is actually related to torque because torque is proportional to angular acceleration. This proportionality constant is moment of inertia, and moment of inertia definitely a physical aspect of any system. However, this the tangential force and the direction of the rotation of distance is similar as the moment in a mechanical system it actions. So the torque in applying equally in mechanical system as well as in electrical system. That means if you want to transfer the electrical energy to mechanical energy or mechanical energy to electrical energy, that system you need to learn that torque how interrelate, the angular acceleration how interrelate with the linear acceleration, how the radius of the torque actions or the pulleys relate to the action of torque, how the mass of the pulley is influenced for the action of torque, and then eventually how moment of inertia is supportive to make the system action, that transition from rotational thing to tangential thing or somewhere else. Then how to say the energy conservation is actually part of dynamics, that static and dynamic energy how transfer and how the interface is that we discussed that here. Before we talk about the force and the distance of action of force as a moment, but whenever we discuss about force and the action of velocity over this force, that is power. Power itself, we know that is always these dynamic things, and it is thus transformation from statics to dynamics because we are at the interface that to transfer from static to dynamics. So far we study until and unless the friction is static. But whenever we move towards moment of inertia, it is just part of interface between statics and dynamics. That's why here there comes F and V. Actually V velocity, F is force, and velocity force combination is actually power, and power always a dynamic part. So then there is a power or energy, it should be conservation issue. That the initial and final stage, how they are interrelated, how they are actually the conserve the power or energy. So in that case, you should consider that, because think about the, how to say, the hydropower system, that the static case, we consider the water reaches certain level. Whenever it start to fall, if there is no source of water, definitely the level will be drop. That means once transferring from potential energy to kinetic energy, definitely potential energy will be lower and kinetic energy should be higher. So this is the concept of conservation of energy. Think about the battery. Whenever battery without any drawn current through the circuit, then it retain the fullest potential energy. Whenever it draw current through the circuit, definitely the energy transfer from potential to kinetic, and it lose the energy. You know that battery certain time of action, it just consume enough energy that it no more valid for action. But in case if it is rechargeable, then think that continuously you are charging like your cell phone charger battery. So it is actually charging and it retain the same action, that transferring the potential to kinetic energy. In case of the how to say, the water reservoir, wherever we uh, design for hydropower, their source of water also retain almost the level similar. If otherwise it has long dry season, it retain the same level of water, because always there is a supply water from other side, and then it maintain the potential energy all through the season, and it transfer the energy from, like the your rechargeable battery, it continuously providing energy or water, or then it is maintaining the level potential energy. So such potential energy transferring to kinetic energy, and the result and any time this total energy actually conserved, that is the conservation of energy principle. It is also is moving part toward the dynamic, from static to dynamic part. So think that here a ball is rolling the downwards. So what will happen? The consider is, the mga is, yeah, this height is s, but this height is not truly vertical, it is slope. Then think about the frictional effect for the downward slope, it should be higher or lower. Then the transitional kinetic energy should be relating to this. Then rotational kinetic energy should be relating to this. Then the total energy conservation should be transitional and kinetic. Please think that whenever we discuss about the water drawing from a oil using a bucket, the that bucket moving upward is against gravity. It is vertical, but it action in the pulley is transitional force, is transferring from transitional force towards the gravity, against gravity, to get it up. So here also the same thing. Think that there is two part. One is the transitional kinetic energy, another is the rotational kinetic energy. Because the object itself is circular, so there must have a rotational action. Then it is actually following the tangent. So there is a transitional action. The total energy should be designed on the transitional and rotational, and also there is a, because it is eventually it moving from upper potential to lower potential. So MGS action should be there. So seeing that, even depending on the design of your system, whether it is circular or elliptical or whatever its shape, it will also impact your loss or energy in the system. This is some concept that how we can transfer the energy or energy system. So work done by pure rotation, it is look like this. That means you need to know the concept of torque, you need to know the concept of angular acceleration, you need to know the relation between angular and linear acceleration, you need to know between angular and linear velocity. Then you have to know the torque and moment of inertia relation, and eventually it will be the applying stage is in the system, that how mechanical and electrical system can apply those phenomena. Previously, for the linear case, we understood that power is actually F and V. F is force, V is velocity. Now the power is, for the rotational case, tau and W. So please relate to them. V is synonym as W, and tau is synonym of force. So think that they are interrelated. In case of linear, we consider F. In case of rotational, we consider tau. In case of linear, we consider V. In case of rotational, we consider W. So this is the interrelation between time. That power is definitely the work done per unit time. So it should be same, but its form, transformation from linear to rotational is different. Here is also some example that how the tangential and linear phase action. So finally, this is the moment of inertia, this is the force, then this is the relation between torque and linear of moment of inertia and acceleration. So think that moment of inertia is m and radius of action r square, where moment was that f and r. So torque is equivalent to moment, torque is equivalent to force, torque is equivalent to moment of inertia and angular acceleration. So if you consider the part of a circle with different things, then we can consider the whole moment of inertia. Even moment of inertia also can action in a not only in the circular, also in a square. Then it should be different action. Here for biomedical engineering, this part is very important. Also for the medical physics, they also studied it, that how the muscle actually, you know that you need to draw or pull certain massive thing. So how much strain in your muscle, you need to understood. So see the similar ideology you can apply for robotic arms to carry certain massive item. So such concept actually is important to know. Here is also the different shape, depending on the shape and size and design, the moment of inertia also vary. So in case of cylindrical shell, it should be like this, solid cylinder should be like this, rod about center should be like this, rod about end should be like this, spherical shell should be like this. Depends in different shape, size, and even weight or the center of mass, it varied the moment of inertia. But we mostly consider in circular case because most of our electrical system, generator, motor, alternator, rotor, even the, let's say, the windmill design, though it is mechanical perspective, but electrical transformation case, you need to know that the circular case, all are actually circular design. So I think we just finish our lecture today. So next discussion should be on Thursday, yeah, afternoon around 2 o'clock. Yeah, you schedule the time. Is it okay? Hello everybody, is it okay at 2 o'clock, yeah, on Thursday afternoon? Okay, thank you for your time. So
Thank you, sir.
please try to study the first 4 or 5 chapter, whatever we discussed before MCO. It should be in your first test, because you know our distribution after MCO we discussed with the management and our program and faculty as well. It rescheduled the course. Now we consist on 2 tests and 2 assignment, but all should be in smart UMS, because we need to a documentary thing. Even in the test, just up before test or 15 minutes before test, we will post the question paper inside the smart UMS like assignment. Then you will download it. You will take the time, whole time for written the answer. Then after answering the question, you just make it uh, as a picture mode. But picture mode is so bulky data. You should transfer in the smartphone can transfer immediately to PDF file. So you made it PDF and then upload in your same system like the assignment. But test should be more dynamic than assignment, because it has very time constraint. But assignment should may not have. But I already made it 50-50. 2 tests will comprise 50 marks and 2 assignment also comprise 60 marks, 50 marks. So you have some liberty on 2 assignment, but you have some constraint and 2 tests. Even final test should be more vast, more rigorous to answer like the 100 marks. Out of 100, it will calculate 30 or 25 for 3 hours. Say for 2 hour test, you will given 15 minutes before and 30 minutes after. That means total 45 minutes you will get to your arrangement and upload the data. So please study. It should be very friendly environment, but don't make it confused or anything to discuss with your friend, because it is beyond our control. We just trust on your ethics or your integrity on the system as a student. Yeah. Thank you all. See you next Thursday afternoon. Yeah. Thanks.